Okay, ladies and gentlemen, we are on Notes 1.4, Properties of Real Numbers, and we are starting on page 8. So let's look at question number 1. Number 1 says that Leela is convinced that the quantity a plus b squared is a squared plus b squared. Do you think she is right? So let's talk about this for a minute. If I take a plus b squared, it would make sense that I could distribute this square through and you would end up getting a squared plus b squared, right? But let's try it with numbers, with real numbers, and see what ends up happening, okay? So let's make up random numbers. I'll say a is 3, and let's say b is uh, 8, for example, okay? So I want to know, is 3 plus 8, the quantity squared, equal to 3 squared plus 8 squared. All right, so let's see if this works. So here I'm going to follow order of operations, so I would get 11 squared. And here, according to order of operations, I would need to do my exponents first. So I would get 9 plus 64. So then 11 squared ends up being 121, and 9 plus 64 ends up being 73. So it's very clear. Here's an example. This is called a counterexample to show that it is not true. She is not right. So no, she is not right. But the question is, how do we fix this so that it is right? So if you don't have enough room for this, you're gonna have to squeeze this in somewhere. And let's do what it says. It literally says a plus b squared. So I'm going to take a square because it's a plus b squared. Okay? And so if I were to do this, this looks kind of like a Punnett square, okay? I'm going to put a here and I'm going to put b here because this is a plus b. Now remember, a plus b squared just means a plus b times a plus b. So I'm going to use the square to do my multiplication right here. So here's my a plus b for one factor, and then my other factor is another a plus b. Okay, and I don't technically need this plus sign right here because it's implied that this b right here is a positive b. So then when I multiply these guys together, a times a ends up being a squared. Okay, and then a times b ends up being ab. So this right here is ab. Okay, and then b times a ends up being ba. And then lastly, b times b ends up being b squared. So I end up getting a squared plus ab, right? So here's my a squared, I've done that one, plus ab, okay? Plus, now, do you guys see how this right here says ba? But I can change it, I can say it in any order I want, so I can say ab again, plus our last one right here, which is b squared, right? So I end up getting, combine these guys together, a squared plus 2ab plus b squared. Okay, so this is my final answer right here. All right, okay, so now let's look at question number 2. Number 2 is done the exact same way. Draw a picture to represent this expression, except this time it's 3 by 2. So when I draw my picture, I'm going to have 3 in one spot and 2 in another on another side. Now you can draw it this way or you could draw it this way. It doesn't matter which way you do it, totally your choice. So I'm going to just go with the first one that I did, and I'm going to label all my information. So I know right here that one side is a plus b plus 1. So I'm going to have an a here, a b here, and a 1 here. And then I know that this side right here is b plus 1. So now I'm just going to go through and fill in all my multiplication. So right here, this means that it's going to be b times a, which is ab or ba. This means it's going to be b times b, which is b squared, again, because when you multiply, you got to add your exponents, okay? And then this one right here is going to be b times 1, so I get b right here. Here, this gives me a. Here, this gives me b, and then 1 times 1 gives me 1. So then I'm going to see, is there anything like each other that I can combine together? Well, I have this b and this b together, so that ends up being 2b. So my final answer is going to be ab, right, because I've got that one done, plus b squared, check for that one, plus I've got 2b right here, so these guys are checks, plus a, this is a check, plus 1. So then that's my final answer, okay? All right, so now let's look at number 3. I want you to try number 3 on your own. Please press pause and then come back to me when you're done and you're ready to check your answer. Okay, you should have a 2 by 2 square where you have A and B on one part and C and D on the other part. Now, it's totally fine if you chose to put the A and the B here and the C and the D here, okay? So then when you multiply it all together, you end up getting AC here, BC here, AD here, and BD here. None of them are like terms, so your final answer would be AC plus BC plus AD plus BD. Now, remember, you can put this in any order you want. So if I ended up getting AC plus AD plus DB plus CB, for example, it's still the same answer because this AC is like this AC right here. Here's my AD. Here is my BC, except I just said CB, and here's my BD. So again, it doesn't matter what order you put it in as long as you have everything that you need. We'll talk a little bit more in detail what it is that you need to have in order to write certain expressions in the correct order, but for right now, it doesn't matter what order it's in. All right, so now we will be talking about the distributive property, which is basically what you did in the examples 1, 2, and 3. You did a lot of distributing. So to distribute means multiplying a number by a group of numbers is the same as doing each multiplication separately. And I'll explain to you what that means a little bit in a few minutes. But for right now, I want you to make sure you get this down. So if you need to press pause to get this down, make sure you do so. Okay? Now, it says, in math, the distributive property means that we blank each piece of an algebraic expression by the term or terms being distributed. So all we're going to have to do is we're going to say that we multiply each piece. Okay? All right, so some examples right here. Do you see how the definition again says that it's multiplying a number by a group of numbers is the same as multiplying each number separately? So here, this x plus 2 is our group of numbers. So all I have to do is multiply this 3 to the x and to the 2. So 3 multiplied by x is your separate multiplication, and then 3 multiplied by 2 is your other multiplication. Now, it's kind of like what we did in our previous example, except it's just a 1 by 2. So here's my 2, I've got my x and my 2, and then my 3 goes on the outside, so I end up getting 3x here, and I end up getting 6 here, so that's why 3x plus 6 is the answer. Now, obviously, you don't need to do this type of work for this question when it's just one term multiplied by several terms. But when you have more than one term right here like this, you are going to want to have a box because it's going to make things easier for you. Okay? So basically, all I'm going to do is I'm going to say this is 4 and this is A. This is 3x and this is negative 7. So when I multiply this guy right here, this 3x by this 4, I end up getting 12x. Okay? And when I multiply 3x by A, I end up getting 3xa or 3ax. When I multiply negative 7 by 4, I end up getting negative 28. And when I multiply negative 7 by A, I end up getting negative 7a. So then altogether, my answer would just be 12x plus 3ax minus 28 minus 7a. And again, don't worry about the proper order. We'll talk about the proper order in future lessons. We are going to skip question number 6 because it's very much like question number 2 that we had done on the top right here, and we'll get more practice with those questions in class. So let's look at number 7. And number 7, I don't need to do a box because it's just this on the outside that's being distributed. Now technically, it's like you're distributing a negative 1. So it's negative 1 times 7x cubed plus 3x squared minus x minus 1. But really, all you have to do is just distribute the negative through. So everything becomes its opposite sign, which is the same thing as multiplying by a negative. So this 7x cubed becomes negative 7x cubed, which should make sense to you again because negative 1 times 7x cubed is negative 7x cubed. This positive 3x squared here becomes negative 3x squared. This negative x becomes positive x. And this negative 1 becomes positive 1. So I've distributed the negative through. Again, writing it out like this is not necessary, but you may use it if it is helpful to you. All right, So now that's the distributive property. We're going to talk about something a little bit differently now. Number 8, Susie draws the following picture to represent the sum 3 plus 4. So here's our 3, and then here are our 4, right here. Okay? And then looks at this picture from the opposite side of the table and says, you drew 4 plus 3. Is Ben's thinking correct? So are you allowed to say, is Ben allowed to say that it's 4 plus 3 and not 3 plus 4? Absolutely. So yes, his thinking is correct. Because you can add in any order you want. And hopefully you know what property it is that says that you're allowed to add in any order you want, okay? All right, so number 9, Susie adds more to her picture and says the picture now represents 3 plus 4 in parentheses plus 2. So right here, here's my 3 plus 4. It's this whole thing, this 3 plus 4, except the 3 plus 4 is really, truly the 7 that we have here, right? So here's my 3. Here's my 4, sorry, here's my 3, here's my 4, so, but all together it makes this red piece right here, okay, plus the 2 on the outside. So I've got this 2 right here, just hanging out over here, okay? So how might Ben interpret this picture? Well, you've got several different options. Go ahead and write down what you think the answer would be. So Ben could look at it several different ways. He could look at it as 2 plus 3 plus 4, okay, or 2 plus 4 plus 3, or 2 plus 4, all in parentheses, plus 3. There's lots of different options, okay? Now, in number 10, Susie then draws another picture of squares to represent 3 times 4. Ben moves to the end of the table and says, from my new seat, your picture looks like the product 4 times 3. What picture might have Susie drawn, and why would Ben see it differently from his viewpoint? So Susie could have drawn, just like we talked about earlier, 3 by 4, she could have drawn it like this. Right? Here's my 3, and then here's my 4. And Ben could look at it differently and say, you know what? That's not how I see it. I see it like this. So here's my 4, and here's my 3 is what Ben would say. But it's basically the same thing because altogether, doesn't matter which order you do it in, you've got 12 boxes. So the examples, question number 8 and 10 talk mostly about the fact that you're allowed to change the order, which is the commutative property. So the commutative property of addition says that if a and b are real numbers, then a plus b is the same thing as b plus a. You're allowed to change the order. And the commutative property of multiplication says that if a and b are real numbers, then a times b is the same thing as b times a. Now, question number 9 talks more about changing your groups. So in question number 9, do you see how here 3 and 4, you're changing the groups on 3 and 4, but here you have 2 and 4 together. So you're changing who's in the groups, okay? And that's what the associative property is saying. The associative property of addition says that if a, b, and c are real numbers, then a plus b together plus c is equal to a plus b plus c together. Okay, so notice how the groups are changing. And then the associative property of multiplication says that if a, b, and c are real numbers, then a times b together times c is equal to a times the quantity b times c. Okay, so now we're going to be looking at how can we apply this information to something called proofs. But before we talk about proofs, we're going to talk about flowcharts. So question number 1 says, use these abbreviations for the properties of real numbers and complete the flow diagram. C plus will stand for the commutative property of addition, CX for the commutative property of multiplication, A plus for the associative property of addition, and AX for the associative property of multiplication. So this might seem a little weird at first, but if you really pay attention to what we're talking about, hopefully it will make a little bit more sense to you, okay? Take your time with this. Do what you need to do in order to get yourself to truly understand what's going on. All right, so we are going to go from here to here. We're going to figure out what is changing. So if you guys notice in the first example right here, we've got x plus 4 first, and then we have x plus 4 second. So here's this right here. Those are identical, right? And then right here we've got 5 times a plus 2x times y. And here we've got 5 times a plus 2x times y. So if you notice, really what's just happening is you are just simply changing the order. So that's why we've got C plus, because you're changing the order of the addition between those two expressions, okay? So now, in the next example, right here, you have, let's erase this so you can kind of see it a little bit better. You have 2x right here, 2x right here times y, okay? And here you have this y right here times 2x. So if you notice, what's changing here is your order. So again, you're changing order, but this time it's multiplication, so this is the commutative property of multiplication, okay? So then, next example, we'll go from here to here. So let's go ahead and do that. If you look at it, what's changing in this example is you have 2x in parentheses here with the y on the outside, but over here you have the 2 on the outside with the x and the y in parentheses. So you're changing who's hanging out. So this right here, what we're changing is the grouping, so that means that it is the associative property, and what's separating it is the multiplication, so it's associative of multiplication. I want you to see if you can do the remaining 3 examples on your own, and then come back to me to see how you did. All right, so this right here, this blank that you have here should be commutative property of addition, because you're changing the order of the x plus 4 with the 4 plus x. Okay, and then in the next example, you should have associative property of addition, because you are taking where the parentheses are right here, and you're taking the 4 out right here, and you're putting parentheses around a different group. So that's the associative property. That property says you're allowed to change that. And what's separating the 4 from everything else is addition, so it's the associative property of addition. Okay, and then lastly, you're taking this whole entire group and you're placing it before the plus 4. So the plus 4 goes at the end, so you're changing the order, so you should have the commutative property of addition. All right, last example, number 2. Let A, B, C, and D be real numbers. Fill in the missing term of the following diagram to show that the quantity A plus B together plus C and then plus D at the end is sure to equal A plus the quantity B plus another quantity C plus D, okay? So if you look at this right here, A plus B is in parentheses. Now it's a different group. You've got B plus C, okay? And lastly, our goal is to go from this example right here. By the way, this is associative because you're changing the groups. So you're trying to figure out how to play around with the parentheses so that we can go from here to here. I want you to press pause, see if you can figure out what the missing expression is here, and then come back to me to see how you did. Okay, so hopefully you should have that the parentheses that you have right here ended up switching over, and it ended up becoming from here to here. There wasn't enough room for me to fill in here, so I just wrote it underneath. But the parentheses here, these inner parentheses still stayed around the B plus C, and then in the next example, you move the parentheses from the B plus C to the C plus D.